Hey, what's up guys, welcome back to another video. My name is Alex and today I'm checking out the new Asus Rog Strix Z370E motherboard. I also have the Z370F motherboard as it's very similar, so I'll just quickly point out the differences between the two, and for the rest of the video I'll just focus on the Z370E. So the Z370E is the more expensive motherboard, coming in at about $370 in Australia and $210 in the US. The Z370F is slightly cheaper at about $330 in Australia and $195 in the US. I'll have links in the video description so you guys can check out pricing as well in case you're watching this video later on, as the prices can fluctuate from the time I recorded this video. So physically looking at the two boards, they're very similar. In fact, the PCB layout is near identical, similar to how the Z270E and the Z270F were with the previous generation. Now the main difference you'll notice with this generation, however, is the difference in color, with the more lighter silver color on the Z370E compared to the darker gray on the Z370F, and that's relating to the heatsink and the I/O cover there. Other differences are that the Z370F doesn't feature the internal USB 3.1 Gen 2 front panel header just in this area here, and also the Z370F doesn't have built-in Wi-Fi, which for me is pretty much a deal breaker. So basically the only reason why you buy the F is if you don't care about the Wi-Fi, otherwise you'll have to pay the extra dollars and get the E. Now everything else between the two boards will be pretty much the same, so for the rest of the video I'll focus on the Z370E. Firstly, let's check out what comes inside the box. You'll find the Wi-Fi antenna just in this box here. This one is just for the Z370E, of course. You'll get a nice door hanger. I guess I'll just add that to my collection. Of course, you'll get the manual, you'll get a driver's disc, although you should check the Asus website for the latest drivers that you can download from there. You'll get a set of ROG cable labels. You'll get 3 ROG stickers that you can apply to your fans if you want. There's also a one-page instruction on how to install the included VRM fan holder, and then there's 20% off of Cable Mod cables, just in time for the release of Cable Mod's new Pro cables. So here's the two codes from the two motherboards to whoever wants to try and use them first. Further from that, you'll find the I/O shield. There are 4 SATA cables, a temperature sensor cable, a 50/50 RGB LED extension cable, an addressable RGB LED strip extension cable. There's the VRM fan holder that I mentioned previously. There's a 2-way high bandwidth SLI bridge, a CPU installation tool if you need it, it's there, a bunch of small zip ties, and then of course 2 sets of small screws, one for the M.2 mount and the other for the custom 3D printing mounts that this board supports. So both motherboards are of standard ATX size, and as the name suggests, they're on the latest Z370 chipset and feature the new LGA 1151 Coffee Lake socket. So they will only support the new Coffee Lake 8th Gen CPUs such as the i7-8700K that I have in the socket right now that I tested with the Z370E. So keep in mind that older generation CPUs such as the 7700K and the 6700K, so 6th Gen and 7th Gen, they're no longer supported on this platform. So the motherboard will of course support 64 gigs of dual channel DDR4 RAM with frequencies of up to 4000 MHz, although note that 4000 MHz will not be easily achieved out of the box and some tinkering may be required. Now I did test the motherboard with 3200 MHz DDR4, and upon enabling the XM3 profile it worked without any hiccups. So you'll get 3 16x length PCIe lanes. The first 2 16x length, you'll find that they do have the Asus safe slot reinforcing, and in terms of PCIe lane allocation, they'll be wired at 16/8, and then the bottom one is wired at 4x only. So you can run, of course, SLI graphics. You'll be using the first 2 with the safe slot reinforcing on them, and we do have 2 graphics cards populated in there. They'll be running at 8x and then 8x. And then there are also 4 1x slots as well, so you can see those here. Now in terms of M.2 drive support, the board can take up to 2 2280 standard M.2 SSD, so there is one here, and I do have a Samsung SSD in there at the moment, and then there is another one underneath the heatsink just here. And it also supports Intel's new Optane drives as well. The main M.2 socket they should use is the one found underneath the PCH heatsink, so it's just in this area here. That can be accessed by undoing just these 3 screws. You'll find a thermal pad underneath with the lower section of the cover acting as a heatsink for the SSD itself once you have it installed in there. What you should know, however, is that, and this is the information that I was able to pull from the manual, is that only the bottom M.2, so that's the one here, that will be considered as the main M.2 slot. Only this one will support both SATA and PCIe NVMe SSDs. The one in the top there, this one will only support PCIe SSDs. So in the manual it says that it does not support SATA. So unfortunately I don't have any SATA drives on hand at the moment to test, but the information is from the manual, so I assume it's correct. Now further from that, the bottom M.2 slot, so just the one here, this one will share bandwidth with SATA port 1, so that'll be the first SATA port just on the edge here. and then the top M.2 slot, so this one here, this one will be sharing bandwidth with SATA ports 5 and 6, so there's just the last 2 SATA ports on the side here. Motherboard also has the built-in Supreme FX audio, so that is just in this area here. That'll offer an 8-channel high-definition audio codec. Now for my performance testing, I used the i7 8700K and tested at stock clocks with MCE enabled as well as disabled, and also overclocked the CPU to 5 GHz. Although 5 GHz proved more difficult and more unstable on this motherboard when compared to the Maximus 10 Hero, which I tested recently as well. I'll get further into this in a minute. But for the rest of the test system, it consisted of 32 gigs of G.Skill Trident Z RGB, 3200 MHz DDR4 RAM, a 1TB Samsung 960 EVO as the OS drive, and then I also had a Founders GTX 1080 graphics card. I used the Noctua NH-U12S as the cooler and worked perfectly fine even with my applied 5 GHz overclocked settings. And for the power supply, I used the Cooler Master V1000. So you'll see the results on screen and notice the multi-core improvement in the scores with MCE enabled. So this is the multi-core enhancement feature that essentially takes the highest single core frequency, and in case of the 8700K, that's 4.7 GHz, and applies this frequency to all cores. Which is why the Cinebench R15 single core scores are the same between MCE enabled or disabled, as the highest single core frequency in that instance was just a 4.7 GHz. You'll see the slightly higher score with my 5 GHz overclock there on the single core. But then of course with MCE enabled, you'll see higher scores as well when it comes to multi-core applications. Now the Asus motherboard will come with this feature enabled out of the box, which will essentially overclock your CPU, even if your particular CPU doesn't properly run at this overclock frequency on all cores. So just a thing to be mindful of. You can of course disable this in the BIOS, but upon first boot, it will be enabled. However, even with the performance bump that you get by having MCE enabled, I don't quite like this feature, as you'll see a lot more voltage being applied to the CPU and therefore increasing temps quite a bit. So during stock operations with MCE disabled, I was seeing the voltage fluctuate between 1.13 to 1.31, with temps staying in the upper 60s during the high-load test that I did. And then with 3D Mark, which better represents hardware load that you typically see in a gaming scenario, I didn't even see the temps reach 60 degrees, and they stayed sort of in the upper 50s there. So with MCE enabled, there was a slightly increase in voltage, so I did see the voltage jump between 1.29 to 1.4. This of course bumped temperatures quite higher. They were in the upper 80s during the high-load test and about mid-70s during the 3D Mark test that I did. Now when it comes to the 5 GHz overclock that I did, if you look at the overclocked scores, you can actually achieve better scores at lower voltages and temps by simply overclocking yourself rather than using the MCE feature. So a positive on this motherboard, however, was that with the stock CPU operation, I didn't see any voltage spikes that the Maximus 10 Hero was getting during my test, and these temps definitely stayed much cooler there at stock clocks. So when you compare this stock operation to what I was getting on the Maximus 10 Hero with the same Noctua air cooler and the exact same CPUs, the temperatures on that motherboard were spiking into the mid-90s due to the very high voltage that was being applied by the motherboard. So yeah, as far as I know, this motherboard didn't suffer for the same sort of voltage spikes at stock clocks that I was experiencing with the Maximus 10 Hero. Now with my 5 GHz overclock, we can see a constant improvement in the scores of about 13.49% on average. Compared to having MCE enabled, we were getting about 8.16% increase in terms of performance from the stock operation. So the one thing is, with this motherboard, however, I did struggle to achieve this 5 GHz overclock at the 1.25 volts that I was able to do so with the exact same 8700K CPU on the Maximus 10 Hero. In fact, I had to bump up the voltage quite a bit to 1.35 volts in the BIOS, pretty drastic increase compared to what I was able to achieve with the Hero. I also had to play a little bit with the load line calibration. I had to increase this to level 7, which was the maximum supported level in the BIOS. V-drop kept kicking in during high load, and I was lowering the voltage way below to what I was setting it to in the BIOS, and therefore the 5 GHz overclock kept crashing under high load. So this is a direct result of the lower power delivery found on the Z370E compared to the Maximus 10 Hero. But even with the 1.35 volts on the V-core applied on the BIOS and LLC set to level 7, the CPU Z and hardware monitor voltage readout that I was getting was about 1.28 and pretty much stayed set at that level. So it goes to show how a better power delivery system and using higher quality components between the Maximus 10 Hero and the Z370F does help in terms of overclocking and getting a more stable power delivery through the CPU. Still, even with these settings and the higher voltage applied, as well as the Noctra air cooler that I was using, temp stayed in the mid 80s at high load, and with 3D Mark the temp stayed in the lower 70s. Better scores with slightly lower temps than the one I was getting with MCE enabled. So I definitely wouldn't rely on the MCE feature. I would actually pretty much disable it completely in the BIOS. And if you do want that extra bump in performance and spend an afternoon tweaking your settings, find your best overclock at the lowest voltage you're comfortable with in terms of the temperatures that you're getting, and in the long run you'll be much better off. Now let's talk about onboard connectors. So there are 6 SATA 3 6 gigabit per second ports just in this area here. There are a total of 6 USB 3.1 Gen 1 or USB 3.0 ports, depending on what you want to call them. So there are 2 on the rear. And then there are 4 via the 2 internal headers. So there's one header here. This one's actually turned 90 degrees around. And then there is another header just at the bottom there. There's also a total of 6 USB 2.0 ports. So there's 2 on the back and then 4 via the 2 ports just at the bottom of the board here. So there is one USB 3.1 Gen 2 front panel port on the motherboard. So that one's just here. This one is only present on the Z370E, just as I mentioned at the start of the video. You won't find this on the Z370F. However, you do get 2 USB 3.1 Gen 2 ports on the rear I/O. One is Type A and one is Type C. In terms of Aura RGB headers, you'll find one standard 50/50 RGB LED strip header just here. There's another one at the bottom here, and then further to that you also get an addressable RGB LED connector just on here. So with this one you can connect addressable RGB LED strips, and you can connect the individual LED on the board itself. That's sort of what addressable means. In terms of fans, you'll get 6 header on the motherboard. So there's 2 chassis fans. So there's one here and then one here. Then of course you get the CPU main and the CPU optional just here. There's also an AIO pump header just here. And then at the very bottom, there's another header that's labeled M.2 fan. Now, of course, you can use this header just with normal fans as well. You don't have to use this fan specifically for the M.2. So all these 6 ports, they'll run a maximum of 1 amps or 12 watts of power each. And of course, they will all support PWM control. Now, unfortunately, there are no water cooling pump headers or any high amperage headers found on this motherboard. There's also no water cooling friendly features, so there's no like temperature sensors for water cooling or anything like that. There's also no power and reset button on this motherboard, and there's no postcode readout as well. Further on the rear I/O, some of the ports that I didn't mention before, of course, you get the Wi-Fi antenna connectors. So this one again is on the Z370E only. The F won't have this. Then you'll get a display port and HDMI output. There's also a DVI output as well. You get a gigabit Ethernet, and then all of your audio ports as well. Now, one thing you'll notice on here, compared to the Hero motherboard that I looked at recently as well, this one doesn't have any USB BIOS flashback feature. So just keep that in mind. If you are interested in that feature, you'll have to look a step up from this motherboard at the Hero. In conclusion, I like the look of this motherboard. I like the color difference between the Strix Z370E and the Z370F, even though the boards look pretty much exactly the same. They've done that sort of differentiation with the colors. And also the Z370E is much cheaper than the Maximus 10 Hero. However, in terms of overclocking, it did struggle a little bit when compared to the Hero, but still the 5 GHz overclock was achievable with a bit of further tinkering, and it still maintained decent temps even on air. So if you don't mind the slight downgrade in terms of overclocking performance, if you don't care about the water cooling friendly features that this motherboard doesn't have built in like the Hero does, or if you don't mind not having the USB BIOS flashback, then the ROG Strix Z370E or the Z370F are both great and much cheaper ROG alternatives, sort of stepping down from the more expensive Maximus 10 Hero. But anyways, I hope you guys enjoyed this video, and if you did, then hit that like button and also consider subscribing to my channel. I put a lot of time into these videos, and subscribing definitely helps me out a lot. Stick around if you have time, maybe check out some of my other videos, and hopefully I'll see you in the next one. Cheers.